Assalamualaikum everyone. My name is Ikhtiar and welcome to today's video tutorial. Today we're going to zoom in a classic encryption technique that has withstood the test of time, the Caesar Cipher algorithm. Before we jump into the details of Caesar Cipher algorithm, let's lay down the groundwork by understanding what is cryptography and its relation with Caesar Cipher algorithm. So, cryptography is the science and art of secure communication. It involves techniques and methods used to protect information from unauthorized access or alteration. In a world where data is constantly flowing across network, ensuring the confidentiality, integrity, and authenticity of that information is absolutely crucial. So cryptography is made of two things. One is encryption, the another is decryption. So encryption is the process of transforming readable or plain text data into an unreadable or ciphertext from using a specific algorithm and a key. So this specific algorithm is the Caesar cipher algorithm that we are going to talk about. And the decryption is the opposite of encryption. It involves converting the ciphertext or the unreadable text into its original plain text form, making it readable again. So, so there are many algorithms used in cryptography. One of them is the Caesar cipher algorithm. So let's understand the Caesar cipher algorithm. So the Caesar cipher is a classic encryption technique that dates back to ancient Rome. So when Julius Caesar needed a secure way to communicate with his generals on the battlefield, this is where the Caesar cipher makes its entrance. It is named after Julius Caesar. So it involves shifting the letter of the alphabet by a fixed number. So the main principle is uh, it shift each letter in the plain text or the readable text by a fixed number of position in the alphabet. So it will be easy to understand with some example. So before jumping into the example, let's see the formula. So the plain text is represented by the alphabet P. Here P is the value of the alphabet. C is this ciphertext and the key is represented by K, and the formula for encryption is C equal to P plus K, the index of the plain text plus the key is equal to the ciphertext. Suppose we have some alphabet A, B, C. So the index value will be 1, 2, 3. Index could be start from 0 or 1. Here we have started the index from 1. So the index is going to be from 1 to 26 as the alphabet are 26. So if the key is 3, then we are going to transform the readable text ABC into ciphertext by adding the index value P, which is 1 for A, and the key value, which is 3 for this case, then it will be 4. So the index value of D is going to be 4. So 1, 2, 3, and 4. So this is how the Caesar cipher works. Here is one more example. So these are the index value from A to Z. A is 1 and Z is 26. Here we have the plain text P, which is apple. Then we have the key value, which is 5. And then the cipher text C equal to P plus K. So this is how the encryption works for Caesar Cipher algorithm. The first row, we have the plain text P, which is apple, then PI, which are the index value. So A for 1, P is 16, and L is 12, and E is 5. These are the index value. Then we have the K, which is 5 for every case. Then we have to find out the CI, which are the summation of PI and K. So for A, the PI, the index value is 1 and the key is 5. So the CI would be 6. For P, it will be 21. For L, it will be 17. For E, it will be 10. So the index value of F is 6. So the cipher text for A would be F if the key is 5. So this is how the encryption works. First, we have the plain text apple. Then we need to find out the index value of each alphabet. For A is 1 and so on. Then we need the key value, which is 5. Then we need to sum up the two values, the index and the key value. So it would be 6. And the alphabet associated with the index value 6 is F. So the cipher text for A would be F, for P would be U, for L would be Q, and E would be J. So this is the encryption, and the decryption is the same. It's the opposite way. So from cipher text, we have to convert into plain text. So the key would be same, but the formula would be P equal to C minus K. We need to subtract from the index of ciphertext and the key. So here is the example. First, we have the ciphertext FUUQZ for apple. Then we need the indexed for each alphabet. For F, it would be 6. For U, it would be 21, and so on. The key would be 5 for every alphabet. Then we need to find the PI, which is the index of the plain text. So it would be CI minus K. So for F, the CI index is 6 and the key value is 5. So the PI would be 1. For U, it is the index value is 21 and key is 5. So it is 16 and so on. So the index value of A is 1. That's why we have A. The index value of P is 16, L is 12, and E is 5. So this is how the decryption works. It's the opposite of encryption. So these are the basics of Caesar Cipher algorithm. There are some exceptional case which are going to discuss. So if the key value is quite large, then we have to tackle it in some other way. So let's take the same example, apple, but the key would be different, which is quite large. 3157. The formula would be the same, C equal P plus K. So if the value of Ci, which is the ciphertext index, is greater than 26, then we have to mod it with 26, because the alphabet is from 1 to 26. If the value is greater than 26, there won't be any alphabet to choose. So we have to mod it with 26 to convert the greater number between 1 to 26. So here is the same Apple example, but the key is different. Here we have the plain text Apple, the plain text index, the key value, which is 3157, then the ciphertext index, which is the summation of plain text index and the key value. For A, it would be 3158. So we have to mod it with 26. So 3158 mod 26 is 12. So the new CI value would be 12, and the alphabet associated with 12 is L. So the C would be L for A if the key is quite large. So it doesn't matter if the CI value, the summation is greater than 26, we have to mod it with 26 no matter what. So this is the encryption for the value of CI is greater than 26. Then, so as for decryption, there are also some exceptional case. So let's understand it. We're going to use the same example, Apple. The ciphertext for Apple is LAAWP for the key 3157. The formula would be the same, which is P equals C minus K. So if the value of PI, which is the plain text index, is less than 1, then we have to use this formula. Here Y represents the value of PI. So let's understand with this example. We have the value C, which is the ciphertext LAAWP. Then the cipher index for this alphabet, then the key, which is 3157. So here is the PI, which is in negative. If the value of PI is less than 1, then we are going to use this formula. So here for L, the ciphertext index is 12, the key is 3157. So if we subtract 12, so sorry, if we subtract 3157 from 12, we get minus 3145. So let's say the minus 3145 is represented as Y. So the absolute value of Y, which is 3145 divided by 26. So it gives the value 120.961. So if the value is in subtraction, then we have to round it up no matter what. If the value is 0.01, we have to round it up no matter what. So the rounded up value is 121. Then we have to multiply it with 26. So 121 into 26 gives the value 3146. So the last step is Y plus the final result, which is 3146. So y is minus 3145. So here 3145 plus 3146 gives the result 1. So here is the new plain text index, which is 1. So this is how we transform the value if it is less than 1 for decryption. So all of the value are in negative, which means it is less than 1. So we have transformed this value with the same technique. So this is how we use the decryption if the value is in less than 1. So we have implemented this Caesar Cipher algorithm in Python, which we are going to discuss now. So here is the code implementation using Python. The first thing this program is going to do is to take input of the plain text and the key value. Then it is going to call the function encrypt, passing the value, text, and the key. So inside the encrypt function, we have declared an empty string to store the encrypted text. So here is a for loop to go through each and every alphabet in the plain text. So here is the PI, which is the plain text index, which is calculated by the ordinal value. So the ord of char gives the ASCII value, and then we have subtract it with 96 because the ASCII value of smaller a is 97. If we subtract it with 96, it gives the index of 1. So the next thing we did is to calculate the CI value, which is the summation of PI and key. So next thing we have to check if the CI, the ciphertext index, is greater than 26. If it is true, then we have to mod it with 26. So the CHR converts the ASCII value into a character. So the CI, if the value is greater than 26, we have modded with 26, then add 96 to convert it into the ASCII value. Then it will convert the ASCII value into the a alphabet. So if it is true, then it is going to perform this implementation. If it is not true, then it is going to do the normal without mod. So this is how the encryption works. The next thing is the decryption. Inside the decrypt function, we have the decrypt text, an empty string. Then we have the CI and the PI. So PI is this subtract value of key from CI. If the PI, which is plain text index, is less than 1, then we have to transform it into the range of 1 to 26. So here is how we did it. The first thing we did is to divide the PI, the absolute value of PI, with 26. Then we round it up and stored it in the rem variable. Then we multiply it with 26, and then we add it with the PI, which is plain text index. This is how we transformed the value which is in negative into the range from 1 to 26. So these are the implementation using Python. Run the code. So we have to enter the plain text, which I'm going to use Apple, and the key which I'm going to enter is 3157. So it give the encrypted text LAAWP, which we saw in the slide, and the decrypted text Apple. So that's all. Hope you understood the Caesar Cipher algorithm.